Steam engines were used to power locomotives during the Industrial Revolution. However, modern steam engines, which power steam turbines in power plants, are a bit more sophisticated. First, we start with a boiler. To get the water in this boiler boiling, we apply a heat source. Now, if we have a boiler that's closed and we apply heat to it, the water will increase in temperature and start boiling, and the pressure inside the boiler will continue to increase. The pressure can rise much higher than atmospheric pressure. Eventually, the pressure would get so high that the boiler would crack and even explode, allowing the steam to exit. But we use the pressure from the steam to create electricity. If we attach a pipe to allow the steam to escape, it will begin to escape at great speed. This fast-moving steam can be used to generate electricity if we attach a turbine. The fast-moving steam hits the blades of the turbine, causing them to turn. But we don't just let the steam escape out into the atmosphere. The steam you may see coming off of power plants is not the steam that is being boiled in the boiler. This steam that you see coming off of cooling towers is actually generated in a cooling process we'll see later. Instead of allowing the moving steam to escape, it is brought into a vessel called a condenser. It is possible to create a steam turbine generator without a condenser. However, using a condenser makes the process of generating electricity much more efficient. So after the steam moves past the turbine, this turbine can be connected to a shaft, and that shaft can then turn an electrical generator, creating electricity. The shaft is turned at a constant rate to create alternating current electricity. So what happens to all the steam once it enters the condenser? That's where the cooling process comes in. If we had no cooling process within the condenser, the pressure between the boiler and the condenser would eventually equalize. That means that the steam would keep piling up in the condenser, and then there'd be no difference in pressure between the boiler and the condenser, and the steam would stop moving through the turbine. Cooling water is moved through pipes, allowing hot steam to condense on the pipes. Because the steam condenses onto the pipes, the pressure inside the condenser stays low. The pressure stays low because steam is not allowed to build up in the condenser, as it condenses down into water when it hits the cold pipes. The cooling water for the condenser can come from a source such as a river and can be returned to the environment. Or cooling towers can be used which use water, and the water is evaporated by the heat from the condenser. It's more efficient to use a condenser than to allow the steam to escape into the atmosphere. The reason why is the pressure inside the condenser is lower than atmospheric pressure. Because the cold pipes condense the steam, there's very little pressure inside the condenser because there's very little steam when it is cooled. However, without a condenser, the pressure on the opposite side of the turbine from the boiler would be at atmospheric pressure. So if we use a condenser, there's a greater difference in pressure between the boiler and the opposite side of the turbine, which means the steam can move through the turbine faster and create more electricity. As steam condenses inside the condenser, it turns back into liquid water, and this liquid water starts piling up. Water moves from the boiler to the condenser as steam, and it moves through the turbine, creating electricity. To keep this cycle continuous, so that the boiler doesn't run out of water, water is pumped from the condenser into the boiler. This pump requires some input of power, but the input of power to pump water from the condenser to the boiler is much less than the power received from the turbine. Now the cycle is complete. Water is inside the boiler. When heat is applied to the boiler, some of this water starts to become steam and pressurizes the inside of the boiler. The high pressure from the boiler forces the steam to move through the turbine at a high speed, creating electricity. The steam then moves into the condenser, where it is cooled so that there is a low pressure inside the condenser, and this keeps the steam moving through the turbine. The water which is condensed in the condenser is then pumped back into the boiler.